Hi, I'm Emma Borkowski. I'm an assistant professor in the Department of Pathobiology here at the Ontario Veterinary College, University of Guelph. This is the Hive Centre where we've done a lot of research on goat immune responses to parasites, and I'm happy to show you around the lab and show you some of what we do, so come on up. These are some parasites that we collected from small intestine of a sheep that died of parasitism some years back. It's the same species as we see in goats. And there's around 178 of them based on the label on the tube in here. So they're very tiny as adults, these worms, but they do have a massive impact. And 178 may sound like a lot, but it's actually not that many. In animals where we see them getting sick, they'll often have tens of thousands of these worms all throughout their gut. Every goat that's out grazing on pasture anywhere in Ontario, or even in the rest of Canada, is going to be exposed to nematode parasites. They're ubiquitous. Every farm has them. And those parasites can cause quite a bit of disease when they get to high enough burdens. And so it's a real challenge for farms, especially organic farms where we don't have medications that we can use on a regular basis to keep the animals healthy and productive and keep them protected from those parasites. And so one of the potential sustainable solutions that organic farms are very interested in, and also conventional farms have become more interested in, is trying to find animals that are better able to make immune responses to those parasites so they are able to control the parasites better on their own with less input from the farmers. And so that's where our project comes in, because we sort of started out doing a lot of work in sheep, which have the same types of parasites as goats, and have found that you can measure antibody responses to indicate which animals are better at making an immune response to the parasites and therefore have fewer parasites. And then those responses can be selectively bred for. We can breed for better animals over time. Today, my team is getting ready to go and sample from some of these goats. We're going to be collecting some fecal samples to monitor their parasitism levels, and we're going to be collecting some blood samples as well so we can look at their circulating antibodies in their blood, and also we're collecting saliva samples to look at their salivary antibody levels.
Yeah. Oh, we're really chewing. There we go. Oh, that's a good goat.
Oh, that's a good goat.
That's a good goat.
Good goat.
That's a good goat.
Yeah.
Good goat.
Oh, that's a good one.
So when a goat takes a mouthful of pasture, if it's on a pasture that goats have been grazing before, in that grass there's going to be some infectious parasitic larvae. And those larvae have a marker on their surface called carbohydrate larval antigen, or CARLA for short. And when the goat actually eats those larvae, the immune system is exposed to that CARLA marker, and then antibodies are produced in response to the marker. And what those antibodies do is they will actually bind to larvae that the animal ingests, and it will mess with their movement. So they're not as able to actually move through the gut and establish an infection. So more antibody means fewer parasites that actually survive.
So as I'm taking them out after this bun, I'm just doing a preliminary check just to see how much saliva I have right now in them. Some animals, when we do the collection, are producing more saliva than others. So we can see here a nice contrast between the two. They have had tons of success with this test in New Zealand in deer and sheep and cattle, but the one caveat that's different is they graze all year. And so here on Ontario, we have just a finite period. And so they had recently done it in goats, which is great. And they found that they can produce this antibody in exposure to grazing these parasites. And so our group and then an adjacent lab group here at the University of Guelph has had tons of success using this in Ontario sheep. And so we thought if it works in Ontario sheep, perhaps it might work in Ontario goats.
So this is our wet lab station, and in the background a bunch of my students are currently working on processing some fecal samples that we collected from some of our research animals recently. So along the bench kind of down here to my left, we've got our station where we mix up the samples. We've got a couple of paddle blenders, and what they're doing is weighing out a known volume of fecal material so that we can then dilute it in a known volume of salt solution, mix it up, strain out any larger particles, and then the salt solution allows the eggs from the parasites in them to float up to the surface once we put them into our special McMaster slides, where we are putting in a bit of the salt solution with fecal material and eggs in it. They then float up to contact the glass, and then on my right over here, we've got a bunch of microscopes where the students are counting the parasite eggs.
You know what? It was really fun.
The antibodies that we're measuring are being raised against these infectious larvae that the goats are ingesting while they're on pasture. And if they have more antibody, what should happen is they have fewer of those larvae that actually survive to become adult parasites. If you have less adult parasites, you should be producing less eggs that are coming out the back end of the goat. So what we've been doing is following a group of goats over the course of the summer, collecting poop samples from them to track how many parasites they're shedding, and then comparing that back against what's actually happening with their antibody levels to see if those goats that have more antibody have fewer adult parasites and therefore fewer eggs coming out the back end of the goat, as we have seen in sheep before. So this is the magic. This is what the girls are seeing when they do fecal egg count. This little green line here is the grid line. You can just partially see it on this field. These sort of oval ones here with the grayish part in them, that's our nematode eggs that we're counting to try and check the immune responses. And we've got these smaller guys, which are coccidia eggs. It's another type of very common parasite in sheep and goats, but we're not specifically studying them. It's just that we tend to see a lot of them just as an incidental finding. We were working with Gailey, Merck, Ontario Goat, the Canadian National Goat Federation, the Canadian Meat Goat Association, and the Livestock Research and Innovation Corporation, or LRIC for short.
I'm Jean Howden, and I'm the Operations Director for the Livestock Research Innovation Corporation. We're an organization that we want to see more cross-discipline, more cross-sector research and innovation in the province, especially as it relates to livestock.
And so they've really all been great to work with in terms of helping with not only financial support, but with recruiting the farms that we actually had involved in the project, helping us to promote preliminary findings as we've been starting to find interesting stuff, just get the word out there about what we're doing and get interest up in farmers and industry in general.
What she's doing is applicable especially in small ruminants, but it's also in all other livestock. And with climate change, we're going to see more nematodes, more parasites. So the more we can learn about them now is helpful so that we've got solutions that are natural, but also that and when those don't work, we have an option. If we stick with the options we're doing right now of just drenching for parasites, we're going to have a lot of resistance.
So Canadian organic goat farmers, just like all goat farmers, face this challenge with these parasites. And with organic farms, since there are limits on how they can manage the parasites and treatment is not something that can be used as a first resort, many of those farms are actually moving to having their animals indoors all the time. Effectively, pastures are not being used to their maximum benefit because the parasites are such a risk. And so if we can actually find ways of breeding goats that are better able to handle parasites because they've got a better immune response, perhaps we will be able to help organic farms better utilize their grazing resources. Maybe they can extend their season or make more intensive use of the pasture resources that they've got available to them.
So we're here on one of our enrolled producers' farms here to collect our saliva, feces, and blood samples from our 3 different age groups. So right here in front of me, we have one of our adults that's enrolled in the study. Over here in the pen, we've got some of our very playful kids. And then over here in this pen is where we have our yearlings.
In Ontario, we're lucky if we get 4 or 5 months of good parasite exposure in a grazing season. So we didn't actually know if the parasite exposure we had in a given year was going to be enough to actually make an antibody response even as quickly as we saw in New Zealand. So we wanted to test those animals that were sort of in their 2nd year of life, yearlings, to see if it worked out like it did in New Zealand. We also want to look at older animals that were at least 2 years old in their 3rd or higher grazing season in case we needed more exposure stacked up over time. But then the other argument is, well, what happens if their genetics are different than we have here in goats in Canada? Maybe our goats actually are already better at making antibody responses and we'll miss them making that response at the first time if we don't also look at kids that are only grazing in the 1st year. So that's why we wanted to look at a span of different ages to maximize our chances of if there was an effect of the antibody on the parasite levels that we'd actually see it and know when was the best time to actually test them.
After all these smaller samples, what we do is we package them all up and they actually get shipped across the world to New Zealand to ag research. So that's where they will do the antibody quantification. And then it's really nice for me because I just get sent back a data sheet. So for each individual animal, they will report for me what their salivary antibody titer is.
We set out with kind of three major objectives. One was to figure out whether goats make antibody to this carbohydrate larval antigen on parasites. Another was to see if that antibody was associated with differences in levels of parasitism in the goats. And then the third was if we can find that goats with more antibody make less parasitic infection that they're then shedding out to the environment, what's the best age for us to check them? So for the first question of do they make antibody, the answer is a resounding yes. We did find that in our Ontario goats, we had detectable antibody levels. The question of how does antibody relate to parasitism levels got a little bit more complicated. So we found that within a given year, there was no consistent relationship. But because we followed these animals for 2 years, we were lucky enough to follow some of the same goats across both years. And so we were able to have a look at what happened between their antibody levels in year 1, 2023, and their parasitism in year 2. And so that's what these graphs here behind me are showing. So the first is showing the relationship between the antibody levels down here on the bottom, and then the parasitism levels here on the y-axis. And so this is around when the goats were kidding. So it's a very stressful time for them. Their immune response tends to break down a little bit. So we saw a positive relationship. As antibody went up, so did the parasitism levels. But when we followed through into later, after they'd been on pasture for a while, kind of here in the second, third, and fourth graph, now you're seeing that as antibody goes up, the parasitism level actually is going down. And that's what we were hoping to see. So it suggests that now these goats have actually been on pasture for a bit. They're getting those younger parasites from pasture that actually have the CARLA marker, and it lets the antibody do something, and it seems to be doing what we were expecting. What these graphs are showing is the number of animals in our study that had actual protective levels of antibody if we use the standards set out by the folks who developed the test in New Zealand. So green is good. Green is where we want to have animals. And this is 2023 and 2024. We did see that the numbers of animals that had what is determined as a protective level of antibody under New Zealand cutoffs, again, we don't know if it works under Canadian conditions just yet, but we found that those numbers of animals tended to be sort of close to the level of selection we might want to do in kids or yearlings, depending on the year. So we might not have to wait quite as long as we feared we might have to wait to actually test our goats because of our short grazing seasons.
It's definitely a really healthy looking herd.
Happy, healthy.
Well adjusted. I'm Stacey Underwood. I'm the General Manager of Ontario Goat and also a third generation meat goat farmer.
I'm Chris Orr, first generation meat goat farmer in Ontario and chair of Ontario Goat. Ontario Goat is a not-for-profit organization representing the dairy, meat and fiber industries here in Ontario. The research will provide much needed information in regards to parasite load in the pastures and help producers better tackle the parasites that they encounter.
The goat industry has been growing exponentially over the last several years, and we anticipate that trend is going to continue with new people coming in and the demand ever becoming greater.
Already, either myself or my grad students have shared our findings with Ontario Goat at a couple of their annual general meetings. We also have presented at the Small Ruminant Veterinarians of Ontario meeting. So this is not just the farmers that we're trying to reach, but the veterinarians that serve them to try and get the word out. We've done a couple of articles in various goat publications. So a lot of this has been supported by our partners.
Ontario Goat is very proud to be doing a new initiative where we are educating would-be goat producers that are coming in that are maybe interested about it and don't have the knowledge about the industry and are interested in coming in, and we do informational sessions via Zoom and have had a great response from that and look forward to continuing that this year.
As a veterinarian, that's the whole point of the game, isn't it? It's trying to make animals more healthy at the end of the day and give farmers the help that they need in order to raise the best and healthiest animals. The big diagnostic center at the University of Guelph is becoming the first diagnostic center in North America that's going to be able to commercially offer the CARLA saliva test to farmers, starting with sheep farmers because we know there that it works. And so if we can start off by having a North American test center that can actually offer that test to sheep farmers, if we continue with our research in goats to prove that it actually does work if we measure them in year 1 and follow them into year 2, I'm fairly optimistic that we should be able to expand that availability to goat farmers as well. And then they will have an in Canada testing center that will allow them to be able to figure out which of their animals are healthiest.